For most of human history, humanity operated under a comforting assumption. The greatest threats to our existence would always originate from within our own borders. Collapsing economies, devastating global conflicts, or severe natural disasters unfolding on the surface of Earth. But what if the ultimate danger to our species has already crossed into our solar system? At this exact moment, something ancient, completely foreign, and physically impossible is moving silently through the darkness beyond Jupiter, while the rest of the world remains blissfully distracted by routine life. According to a series of deep space telemetry alerts transmitted just 14 hours ago, that nightmare may no longer belong strictly to the realm of science fiction. On May 19, 2026, automated listening arrays connected directly to the Atacama Deep Space Observation Network detected an incredible anomaly. The interstellar object designated as 3I Atlas had just survived a dangerously close encounter with Jupiter. Tracking data reveals that the object did not simply drift past the gas giant peacefully. The event appears to have violently shattered the structural integrity of the body itself. Scientists monitoring the flyby now believe that Jupiter's immense gravitational field ripped open the outer shell of this mysterious traveler, exposing an interior core that had remained sealed away for millions, perhaps even billions, of years. At first glance, official channels downplayed the incident, describing it as a routine gravitational interaction involving an ordinary comet-like object passing through the outer solar system. The raw telemetry, however, tells a profoundly different story. As 3I Atlas descended deeper into Jupiter's gravitational pull, sensitive orbital instruments recorded a massive, sudden surge of energy erupting from the object's core immediately following its closest approach. From an astrophysical standpoint, that energetic spike should have been completely impossible. At a distance exceeding 5 astronomical units from the Sun, ambient space is so bitterly cold that basic chemical activity practically grinds to a halt. Sunlight at that distance is more than 20 times weaker than the solar radiation reaching Earth. Ordinary ice and rock entering that distant realm remain completely frozen, inert, and lifeless. Yet, 3I Atlas suddenly became significantly brighter, hotter, and dramatically more active after surviving the gravitational encounter. It began spewing tremendous quantities of matter out into space every single second, behaving as though a dormant engine buried inside its structure had suddenly awakened. That massive contradiction has rapidly become the center of an escalating scientific crisis. To understand why researchers are so deeply alarmed, you first have to understand what the crushing gravity of Jupiter does to an object that lacks a solid, unified structure. During the close flyby, 3I Atlas passed directly through an extreme gravitational gradient, meaning the side facing Jupiter experienced a vastly stronger gravitational pull than the side facing away. Normally, a dense, rocky asteroid would endure this force with only minor surface distortion. Preliminary structural models suggest that 3I Atlas is not a dense rock at all. Instead, it seems to possess a highly porous internal structure, packed with volatile compounds and ancient interstellar materials preserved since its formation far beyond our solar system. As Jupiter's tidal forces brutally stretched and compressed the object, its fragile interior fractured under extreme mechanical stress. Scientists believe its protective outer crust cracked apart within a matter of hours, unsealing material that had been preserved in deep freeze for unimaginable spans of cosmic time. The sudden fracture of the outer crust is not even the most unsettling part of this event. The real mystery centers on what unfolded immediately after the structural breach took place. Following the initial breakup, space telescopes recorded massive, continuous jets of vapor and high-velocity debris blasting out from the exposed core. The sheer volume of material being ejected far exceeded anything standard cometary physics could account for. Something within the interior of the object appeared to actively ignite, something capable of generating sustained internal heat within one of the coldest regions of our solar system. Researchers now suspect the answer involves one of the strangest and most volatile substances known to modern astrophysics, amorphous ice. Here on Earth, liquid water freezes into neatly organized crystalline structures. In the deep vacuum of interstellar space, where ambient temperatures hover just above absolute zero, water molecules lack the kinetic energy required to form stable crystal lattices. Instead, they freeze instantaneously upon impact into a chaotic, disordered molecular arrangement known as amorphous ice. This unstable material acts like a cosmic battery, capable of storing tremendous amounts of latent mechanical and chemical energy within its disorganized bonds. For millions of years, the core of 3I Atlas likely remained locked in that hyperstable, frozen state. Then, its encounter with Jupiter changed everything instantly. As tidal forces crushed and flexed the core, internal friction generated localized pockets of thermal energy. Under normal circumstances, that minor heat would quickly dissipate into the vacuum of space. Inside a matrix of amorphous ice, even a tiny temperature increase can trigger a rapid, violent chain reaction. As the unstable molecules suddenly reorganize themselves into standard crystalline patterns, they release their stored latent energy all at once. The result is a runaway thermal event within the heart of the object. This means 3I Atlas is actively heating itself from the inside out, boiling ancient, frozen compounds into pressurized gas and firing them out into space through massive fissures across its surface. The object is no longer behaving like a passive piece of interstellar space junk drifting blindly through the dark. It is functioning like an active, thermodynamic system powered by energy harvested long before our own solar system had even formed. What scientists discovered hidden within that venting vapor proved to be far more terrifying than the unexpected energy source itself. When the James Webb Space Telescope redirected its powerful sensors to analyze the glowing molecular cloud surrounding the object, the resulting spectroscopic light breakdown revealed something that should not exist anywhere near our sun today. The chemical signature was so wildly abnormal that it threatens to completely overturn our understanding of interstellar formation processes and the nature of the celestial realm surrounding us. The moment light from the expanding vapor plume was separated into its individual wavelengths, the entire nature of the deep space investigation shifted overnight. Until that moment, mainstream researchers were still holding on to the theory that 3I Atlas was merely a uniquely fragile comet damaged by planetary gravity. Spectroscopy, however, does not yield to comforting theories, institutional assumptions, or carefully curated public narratives. Every single atom leaves behind an undeniable, unique fingerprint in light, and those fingerprints pointed toward an unthinkable reality. Buried deep within the expanding vapor plume was water unlike anything ever recorded inside our solar system. According to the spectral data, the exact ratio of deuterium to standard hydrogen within the escaping water vapor was over 3,000 times higher than the baseline levels found in Earth's oceans. That single measurement instantly demolished every standard astrophysical model detailing how and where interstellar bodies form. To grasp the severity of this discovery, it helps to understand what deuterium actually represents. Ordinary hydrogen consists of a single proton wrapped in an electron cloud. Deuterium, frequently referred to as heavy hydrogen, contains both a proton and a neutron, making the atom significantly heavier than its standard counterpart. When deuterium binds with oxygen, it forms heavy water. On Earth, heavy water exists only in minute traces. Even in the most distant, pristine comets originating from the Oort cloud, deuterium concentration remains extremely low. The readings gathered from 3I Atlas fell entirely outside any known natural spectrum found in our solar neighborhood. This was not a minor chemical variation or a statistical outlier. It was evidence of an entirely foreign isotopic origin. That realization immediately introduced a terrifying scientific reality. Molecules become enriched with high concentrations of deuterium only under hypercold conditions sustained continuously over immense spans of cosmic time. In young planetary systems, temperatures remain warm enough that lighter water molecules stay highly active, while heavier molecules freeze out onto surrounding dust grains. Over millions of years, this dynamic gradually concentrates heavy water into isolated, deeply frozen pockets. To reach the staggering isotopic levels measured inside 3I Atlas, the native environment would have needed to endure an uninterrupted deep freeze near absolute zero. Simply put, This object was not born in a star system resembling our own. Researchers now speculate that 3I Atlas may have formed in the outer fringes of a dim red dwarf system where light barely penetrated the planetary disk, or perhaps near a rogue planet wandering through interstellar space entirely detached from a parent star, locked in absolute darkness for billions of years. The bizarre chemistry alone was not what triggered immediate alarm within classified astrobiology divisions. The true fear stems from the profound implications regarding what kind of life could theoretically evolve within an environment dominated by heavy water. On Earth, complex biological organisms rely on extremely precise, delicate chemical reactions. Proteins must fold into exact shapes, cells must divide at controlled rates, and DNA must replicate through fragile molecular interactions that took billions of years to refine. Heavy water is notoriously destructive to terrestrial biology. In high concentrations, it acts as a lethal toxin because its stronger molecular bonds slow down critical chemical reactions, effectively breaking the biological machinery life depends on. An environment dominated by heavy water would be completely hostile to almost all Earth-based organisms. Evolution, however, is bounded only by chemistry. If a biological system were to originate within a heavy water ocean from the very beginning, its molecular framework would adapt to those parameters naturally. Cellular processes would operate under completely different energy thresholds. Metabolic cycles would move at slower, far more resilient paces, and structural proteins would form around alternative molecular bonds. In short, 3I Atlas may not be an ordinary interstellar rock at all. It could represent the carrier of an alternative biological evolutionary path forged under conditions our planet has never experienced. That stark realization elevated the object from a simple astronomical oddity into a potential planetary threat, shifting top-level government discussions away from mere space geology toward biological contamination, biosafety protocols, and the active arrival of alien chemistry. As governments scrambled to interpret the data, 3I Atlas continued accelerating away from Jupiter on a hyperbolic escape path, having stolen a fraction of the gas giant's orbital momentum during the flyby. Every updated calculation confirmed the same reality. The main body was not bound to our sun. It was passing through our solar system a single time before exiting into the void forever. That limited window sparked a desperate global rush for continuous tracking data. Listening stations across the globe locked onto the anomaly, recording precise thermal signatures, structural changes, and electromagnetic emissions around the clock. As more telemetry poured in, the situation became vastly harder to explain through natural phenomena. Small fragments began separating cleanly from the main body. Initially, astronomers assumed the debris was nothing more than loose rock and ice blasted off by internal gas pressure. The precise tracking patterns of the separation did not match typical outgassing behavior. Several of the detached fragments accelerated at velocities far too high to be caused by natural vapor expansion alone. One fragment in particular drew immediate, intense scrutiny after orbital networks recorded a separation velocity approaching 850 meters per second. That speed should have been physically impossible for natural cometary shedding. Standard comet fragmentation produces slow, chaotic dispersal patterns. This fragment accelerated cleanly, almost as if driven by a controlled mechanical force explicitly designed to launch it away from the host body. The moment that possibility was raised in high-level defense meetings, the entire tone of the investigation transformed. If that separation was executed deliberately, then 3I Atlas was not merely a passive interstellar visitor. It was acting as a delivery mechanism. Even more disturbing, updated orbital models demonstrated that this high-speed fragment was no longer following the outbound trajectory of the main body. Instead, refined gravitational calculations revealed a trajectory that intersected directly with Earth's outer atmosphere. Initial projections pointed toward an entry corridor over remote stretches of the southern Pacific Ocean. Updated high-precision telemetry continuously shifted the predicted entry path eastward, aligning it directly toward one of the most densely populated coastal corridors in South America. For generations, the public has been told that the vacuum of space acts as an insurmountable barrier to life. The interstellar void is saturated with deadly radiation, kept at temperatures near absolute zero, and spans light years of empty space, requiring millions of years to cross. Mainstream science maintained that organic structures would be completely shredded long before reaching another star system, a belief that formed the bedrock of planetary protection policies. The incoming telemetry from 3i Atlas is completely dismantling that assumption. As defense networks closely tracked the fragment descending toward Earth, scientists were forced to confront an unsettling question. If this object truly spent millions of years crossing interstellar space, how could any complex molecular structure remain intact after enduring endless exposure to deep space cosmic radiation? The answers emerging from advanced structural modeling are profoundly alarming. According to the newest spectral data, the fragment is not composed of standard, delicate, carbon-based chemistry. Instead, evidence suggests it relies on a silicon-carbon hybrid molecular architecture utterly alien to terrestrial biology. If validated, it means this object is built from a chemical framework specifically engineered to endure extreme cosmic environments and violent physical entries. To understand the implications of a silicon-carbon hybrid structure, consider what occurs when a typical body enters Earth's upper atmosphere. Traveling at speeds exceeding 12 kilometers per second, intense atmospheric friction generates temperatures surrounding the object well over 1600 degrees Celsius. Under those conditions, standard biological matter is utterly destroyed in seconds. Proteins unspool instantly, carbon bonds snap apart, and cellular structures turn to ash before they even hit the lower atmosphere. Even high-strength aerospace metals experience severe structural degradation under that level of thermal stress. No terrestrial organism could ever survive direct exposure to those entry conditions. Telemetry from the approaching fragment indicates that its outer layers are maintaining remarkable structural integrity despite extreme thermal simulation values. That unexpected resilience has forced researchers to entertain a radical hypothesis. Rather than relying on fragile, carbon-dominated bonds, the fragment appears to utilize silicon-reinforced molecular chains sheltered beneath a complex organic outer layer. Silicon possesses far higher thermal stability than carbon in specific structural arrangements, allowing it to preserve internal molecular systems at temperatures that would completely incinerate terrestrial life. The fragment moving through our skies may be inherently immune to the thermal destruction that normally sterilizes incoming space debris. This leads to a disturbing logical paradox. Why would natural evolution produce an organism pre-adapted to survive high-speed atmospheric entry before ever encountering a planet with a thick atmosphere? That glaring contradiction has driven growing consensus among independent analysts that the structure of 3i Atlas is not entirely natural. Some now openly argue that the object represents an engineered biological transport container designed to protect sensitive